Hey guys, Mr. Phil here with Math Made Easy. Today I want to talk to you about factoring and how a jar of coins can help you understand that concept a little bit better. Okay, so how does a jar of coins help you understand factoring better? Well, I think it's pretty simple because it's here for an illustration. Factoring, I think, is a very frustrating concept for a lot of students because they just don't understand what it serves or what purpose factoring has in math in general. And if you don't have a teacher or tutor that has explained it to you this way before, I think it's really important for you to hear. So factoring doesn't solve for anything in math. Factoring is an organizational technique. And so when you solve, quote unquote, solve a factoring problem in math, you're not really solving. All you're doing is reorganizing a mathematical expression. So much like a jar of coins or a pile of coins, if I wanted to know how much money I have here total, I could take a bunch of coins, count them up, add them together to find the total. That's a completely realistic way of solving this problem. But is it the most efficient? Is it the easiest? Probably not. It's probably actually the more difficult way of doing it and more time consuming. So think of a Coinstar machine. If you haven't seen one of these, they're usually in grocery stores, supermarkets, but it's a machine that basically just counts up your coins for you, and how they do that is the more important thing that I'm trying to compare factoring to. So the way that Coinstar machines do that is they separate the coins into different denominations, more specifically by size, because that's the easiest way to tell, for a machine to tell what coins are different. So by separating them into different piles according to size or denomination, what we can do then is a series of simple multiplication problems to find out how much we actually have of each denomination, and then we can therefore add everything together. That's exactly what factoring does. When you have a polynomial or mathematical expression that you're asked to factor, what you're doing is taking the terms that are alike, putting them into one pile, and then comparing them to the other terms that might be alike or might not be alike, and see how much you have of those. So when you have expressions with parentheses that are combined through division or multiplication, this is exactly the case. They can also be separated by addition and subtraction. We just don't normally do that because that kind of factoring isn't as beneficial. It'll make more sense when you realize and study what basic factoring is, intermediate factoring, and I would say advanced factoring, factoring that you're going to learn starting from Algebra 2 and later. So let's work through some problems together, see how the math actually stacks up with this idea, and let's see if we can get a little bit better at factoring. So let's get to work. Okay, so we're talking factoring basics, and we showed you that example of what coins kind of can represent in a Coinstar machine or a coin counter, and how that process is really similar to what we do with factoring. So let's see us put this into practice now. So basically, when we're factoring, you're trying to look for things that they have in common. This is the first step in factoring. This is the first type of factoring you're going to learn, where you're basically going to look over each term that you see in a problem here, 2x, and then positive 4. This is, of course, positive as well. And you want to see if the integers or coefficients in front of the variables have anything in common that you can factor out, or if there are variables that each term have in common. The reason why I gave you two very similar examples here is because I want you to show you it doesn't matter where the variables are placed. As long as each term has something in common with another term, you can take that out using factoring. So let me erase this question mark so we can solve the first one. And if you look at term number 1 here, we have 2x plus 4. Sorry, 2x, and then our second term is plus 4. So what do they have in common? Clearly, the coefficients 2 and 4 are both factorable by a factor of 2. You can divide 2 by 2, and you can divide 4 by 2. So that's what you want to think of when you're factoring. Also, the operation that we use to factor is division. So how do we do it? We want to write down the thing that we're taking out first. So if we said we're going to take a 2 out of here, we're going to write our 2 first. And then after that, we're going to write a parenthesis. And that's because we're going to show everyone this is what's left over when we divide out a 2. So 2x divided by 2 is x, and 4, or positive 4, divided by 2 is 2. So this is the final answer. That's all you need to do for this problem. If you're wondering, okay, what do you mean divide? Well, if we look at the term 2x and we divide it by 2, and we write it as a fraction, You can see that the top and the bottom have 2 in common, so you can cancel those out or reduce them. Those both become 1s if you want to be specific with your work. So those are both 1, so it's 1x over 1, or just x, right? Anything divided by 1 is just itself. So that's how we get that. That's how we get that answer, and that's how we got the x here. Same thing for 4. 4 divided by 2, of course, is 2. The sign is positive, so that's our answer. Now, if we want to factor out variables instead, we're going to do the same thing. We're going to use the same approach. So I'll erase the question mark, and we'll have the same approach. What does this term have in common with this term? Well, this one has an x. This one has an x, so I know we can take an x out. So we write the x first, write our parentheses to show that this is what's left over after we factor out the x. So xy divided by x is y, using the same logic and process we did here. And then xz here divided by x is just z. And that's our final answer. If you are doubting your answer and you want to make sure it's right, which is I think always a good step, especially to take when you're learning something for the first time or it's new, for factoring, you can always just redistribute this x through to the parentheses or this quantity y plus z here. And if you get the same thing that you started with, you know you did it correctly. So x times y is xy, and then z times x is xz if we write it in alphabetical order. Personally, I'm not too much of a stickler for these. I think in writing them in alphabetical order, that's commonly accepted as standard form, and I'm using air quotes that you can't see here. But standard form in math, usually you write the numbers or the variables in alphabetical order from left to right. So I don't think I need to do this problem for you, but it's the exact same concept. So here I'll write or erase the question mark, and I'll say, for you, those of you at home who are following along, why don't you just take a second and do the problem yourself on a piece of paper. You can even do it in your head if that works, and tell me what the answer is for this. I'll give you a couple seconds here. Okay, so if you got the answer of y times the quantity, oops, sorry, let's undo that. That was a little ran astray with the stylus there. So we took out the y, so then in alphabetical order, they would write a plus x. Now this can get kind of tricky later on, but let's just say because both terms are positive, we can leave it like this. If you wrote an answer like this, where you wrote the x first, because both numbers are positive, it's not going to make a difference. And unless you have a teacher who is very strict with how you write your answers and specifically tells you must always write your answers in alphabetical order, standard form, then of course you want to follow your teacher's instructions. But I'm telling you right now, this answer here is exactly equivalent to that answer there, because both of these signs for a and x, even though you can't see them, are implied positive signs, so it doesn't really matter. Of course, if these were different signs, if the a was negative and then you wrote the a here and didn't write the negative, it would be wrong. We'll get into that later, but this is the basic breakdown of how you factor at a basic level.